Hello friends, let's see an example. Write a program to input some integer and check whether the number is Armstrong number or not. First of all, you have to input some number and program should print whether it is Armstrong or not. What do you mean by Armstrong number? See, if you take a number like, let's say 153, you take this number, okay, and you take individual digits of this number and cube it. So 1 cube, then you add it to the cube of the next digit. So 1 cube plus 5 cube plus, and you take this cube also, 3 cube, and add it. Then if you find the addition of these cubes, you will get 153 itself. Interesting. So this sum of the cubes of the digits, individual digits, if they are cubed and they are added, then you will get the same number, that is n itself. So let's say 370 if you take. If you say 3 cube plus 7 cube plus 0 cube, if you compute, okay, then you will get 370 itself. So such numbers, are Armstrong numbers. That is, in general definition of Armstrong number is sum of the cubes of the individual digits should be equal to number itself. Sum of the cubes of the individual digits should be equal to number itself. So naturally 1. If I ask you, is 1 Armstrong? Yes, of course 1 is Armstrong, because 1 cube is equal to 1. But is 100 Armstrong? No, 100 is not Armstrong, because if you compute 1 cube plus 0 cube plus 0 cube, you will get answer is 1. 1 plus 0 plus 0. 1 is the answer and it is not equal to original number, isn't it? So it is not Armstrong, isn't it? Is 121 Armstrong? No, because if you compute 1 cube plus 2 cube plus 1 cube, you will get 1 plus 8 plus 1, which is 10, and it is not equal to 121, original number. So there are very few Armstrong numbers in this world. In number theory, there are very few Armstrong numbers. Some of the Armstrong numbers we can remember: 153, 370, 371 is also Armstrong. Just check it. So we have to input some number and check whether it is Armstrong or not. The hint is that program, reverse of a number. If you have still not watched that video, you better go to that video, write a program to input a number and print it in reverse order. That video you check, and we just want to make one change in that program and we will get Armstrong number program. Let's see how to do it. In the main, I have declared n is our number, r is the remainder, and we have to find sum, isn't it? Sum of the cubes. So I have declared s will store the sum, and s is initially 0 because we don't know sum initially. Of course, finally s will store the sum, but initially we don't know the sum. So s is 0, and we have used one t variable. This t will be very, very useful at the end of the program. Okay, let's talk about it later. Let's ask the user to input some number, and suppose user enters the number as 153. N is 153. So the final answer should be, it is Armstrong. 153 is Armstrong. Yeah, because 1 cube plus 5 cube plus 3 cube is 153. Now after entering n, what I have done, whatever is the value of n, I have stored it in t. So t becomes equal to n. Okay, so I will just record it. T is 153. Look how that 153 has been safely stored in t. Why that has been done, we will see later. But t records the value of n. Here we go, next part of the program, the core of the program. Now let's use the same loop while n is greater than 0 as in the previous videos. 153 is greater than 0, true condition. Okay, I'll make some working here. N is 153. Okay, then as n is 153, it is greater than 0, then r is computed as 153% n. Last digit will be taken here. 153% n is 3. So r is 3. And then this line is solved. How is this solved? You see, s becomes previous value of s, that is 0, plus 3 into 3 into 3. R is 3. So that is 3 cube. Hence s becomes 27. So what we have done, number was 153, we have taken the last digit 3, we have cubed it and we have added it in S. Time to execute this line, this is n is equal to 153 upon 10, but 153 upon 10 is 15, isn't it? Not 15.3, int upon int it is. So n becomes 15, n becomes 153 upon 10. So what is the new value of n? N is no more 153, n has become 15. Okay? Where do you go after this now? First repetition is over. Now you should go back and recheck the condition. So machine goes and checks back this. It will be, machine goes back and checks this again. So it will be n is 15 now. Is 15 greater than 0 is still true. So this line runs. R becomes 15% 10. 15% 10 is 5. So R becomes 5. Then S becomes previous value of S, which is 27 plus 5 cube, isn't it? 5 into 5 into 5. 5 cube. Hence, S will become equal to 152. Just have a look at that. Check it. It will be 152. And then N will become equal to current value of N. That is 15 upon 10. N is 15. 15 upon 10. 15 upon 10 is 1, not 1.5. So, new value of N now becomes equal to 1. Have a look at it. N becomes 1. Okay, what do you do? Second repetition is also over. Time to go back to while again. Now n is 1. 1 is greater than 0. True condition. Still the condition is true. N is positive, greater than 0. So run this line. R becomes 1% 10, isn't it? 1% 10 is 1. No arguments. 1% 10 is 1. So R becomes 1. And now this line runs. S becomes previous value of S, which is 152. S is 152 plus 1 into 1 into 1. So S will become 153. Then N becomes 1 upon 10. 1 upon 10 is 0. So new value of N is now 0. N is no more 1. N has become 0. Okay. N is finally 0. Now, when n becomes 0, 0 greater than 0 is false. So the loop breaks. Wait a minute. Now the loop has stopped. But now there is one very important work remaining. We should now compare S with the original number. Because S is the sum of the digits, cubes, I am sorry. So that sum should be compared with the original number. Which is the original number? You may say n. No, wait a minute. N is not the original number now. Recall that n was 153, but our program has destroyed it. It has made it 0, you see. It will be ridiculous if you ask, is S equal to n? How can you ask, is sum equal to n? N is no more 153. N has become 0. So, I hope you liked my plan of original number is already stored in T. So, T is still 153. So, if you want to check whether it is Armstrong number, you should ask, is the original number is T, not N. N has become 0. Is that original number 153 equal to the sum? Sum is 153. Yes, they are equal. So, it will print it is Armstrong and else will be not executed. Isn't it? Similarly, you can check it with 370. You can enter N as 370 and by hand, you can check that first N is 370, then R will become 0 first time, last digit of 370, then how S will be computed, then how N will change, it will become 37, if it was 370 it will become 37, and then R will be 7 last digit, then how S will be computed. You will see if you work out with 370 also, S will be 370 finally, and T will be obviously 370 in that case, original number. So if you compare T with S, 370 is equal to 370, it will print Armstrong. This is how we have again used the same logic of percent and division and we have seen Armstrong number. Great, isn't it? One program has produced so many codes and so many examples. Thank you very much.